Hello, everybody. This is the accounting professor, Ben Tchaikovsky. We're here today to have more accounting fun. Can you imagine? So today we're going to be talking about cost, volume, profit, specifically. How do we go through and determine cost functions, determining variable costs, fixed costs, and the margin of safety? Quick disclaimer, anything said in this video presentation is the opinion of myself, does not represent the opinions of any of my employers or any other affiliated organizations, including but not limited to Irvine Valley College and the South Orange County Community College District. Yeah, if my cat decides to show up and Zoom on us, it's going to be a better day. Let's go ahead and take a look at our question today. So today we're going to be looking at how do we go through and determine cost functions, variable cost per unit, fixed cost per unit. So we have over here, ZZix has two types of freeway signs, Barstow and Baker. Well, I drive up on the I-15, so I decided to basically do a little bit of an anagram and reverse it. But we've got W and R that are sold in various states throughout the United States. R sells for $800 each, while W sells for $900 each. Z believes that they can accurately allocate all overhead costs of the two products, meaning that they treat them as two separate companies. Okay, so we want to kind of go through first over here. I'm just going to pause real quick because I deleted something I should not have deleted. With the magic of the backward function up here on Google Sheets, we're back. So when we look at this over here, if we're kind of given data for a period of 2 months, and if we're going through and if the overhead is basically being allocated throughout, basically evenly throughout, or they can accurately allocate overhead costs, there is a formula that we can go through and use to essentially figure out what is my variable cost per unit of activity. And the way we're going to go ahead and do this is the formula that if you're taking my class, I will provide to you on the exam. But what this is going to be is that the highest costs, the highest production costs minus the lowest production costs. And I'm going to be dividing this by my highest production in units minus my lowest production in units. Okay, so, and what this is going to tell us is what is the variable cost per unit. Now, the thought is when we go through and do this, if we know what our total costs are, say for product W of $1,090,000, I can take this value and then take my number of units sold at that total cost times my variable cost per unit. And then I can add basically my fixed costs, which should essentially come over here and get us what we're trying to go through over here and solve for. Now, the important thing is with this is we also want to kind of make sure, well, if it works like this, then to make sure that the fixed costs are going to be the same, we'll just call this fixed cost, what is called X. Right over here, then that means if the relationship holds, then we should have 290,000 equals 400 units, right? Because this is the number of units sold that are being cost basically at the number of units sold at this total cost times basically my variable cost per unit, which is going to be the same plus my fixed costs. X. And we should probably be saying this over here as we'll call this units produced. But, and again, your units produced, units sold, we'll just go ahead and assume that they're exactly the same. So let's go ahead here and put in the values, right? So at the highest production costs, we have $1,090,000. And make this look a little bit nicer. We're going to subtract our lowest total cost over here at 290,000. We're going to have the units here of 2,000 units, and we're going to go ahead and subtract these 400 units. And what this is going to go ahead and give us is we're going to get 800,000 divided by 1,600, or my variable cost per unit of product W. Okay, now I need to make sure whenever you do these computations and, when you're doing these kind of questions, make sure it works, like plug it in, right? Make sure it's happening. So here we're going to get 1,090,000 equals 2,000 units times my variable cost per unit, or 500, plus my fixed cost, which we don't know what those are yet, but we'll know it pretty soon. So over here, 1,090,000, I should say this is equal to is going to be equal to $1 million, which is my total variable cost plus X. So my fixed cost, or X, should be 90,000. Okay. So my fixed costs over here, or product W, should be 90,000. Now, how do we go through and check this? Well, what we're going to go ahead and do is we're going to plug it into this over here. So if we take 290,000 equals 400 units times 500 per unit, which are my variable costs, which I computed up here by taking the high values minus the low values, plus 90,000. Is this true? Well, 290,000 equals 200,000, which is 400 times 500 plus 90,000. Therefore, we know that we computed the variable cost per unit, or 500 is my variable cost. And then we know that our total fixed costs are 90,000. So we know that this is correct. Okay. Now let's go through and then essentially solve this for R, right? We're going to do the same thing. We're going to take the highest production units, or highest production cost, minus my lowest production cost, my R units produced, minus my lowest units produced over here. When I subtract this, I get 60,000 equals minus or divided by 100. Remember, the bottom is in units. So my variable cost per unit is going to be 600. What does this mean? Well, kind of similar to what we were doing over here, is that with the product R, that 263,000, which is my total product cost, is going to be equal to 300 times my variable cost per unit plus my fixed costs. Okay. Similarly, 203,000 is going to be equal to 200 times my variable cost per unit plus my fixed costs. Okay, so we have those two right over here. Now, if I plug this in, if I said that, well, my fixed costs for my variable cost per unit for product R was at 600. So we got 263,000 equals 300 times 600 plus my fixed cost, which I'll call this Y. Well, this means 263,000 equals 180,000 plus Y. My fixed costs must then be 83,000. Okay. So again, when we look at this total kind of cost, right, my total costs are going to be equal to my fixed costs, or my variable costs, plus my fixed costs. That's really what we're trying to go through. And using this, we're trying to basically figure out, well, how much was the fixed cost? How much was the variable cost? So if we know that this is in fact 83,000 for this equation here, then we should also be able to say, well, 203,000 is equal to, which is at the lower level of the production, is going to be equal to 600 times 200 units plus 83,000, which are my fixed costs. So 203,000 is going to be equal to 120,000 plus 83,000. So right over here, my variable costs per unit are going to be 600 per unit. And then over here, my fixed costs are going to be 83,000. So in terms of solving this part over here, given this limited data, what are the variable costs per unit and what are the fixed costs? So given this type of question, if you're taking my class, I will be providing you this formula over here, which is going to be the variable cost per unit of activity. High costs associated with the highest level of production minus the cost associated with the lowest level of production. Good job, Tchaikovsky. You're doing this on the fly. Always fun in units and lowest activity in units. Okay, so this is what's giving this part over here to us. Okay, let's now go ahead and take a look at our next question over here. How many units of W&R need to be sold in order to reach break even? Okay, now there's a lot of different ways we could go through and compute this. Okay, one way I would probably go through, and I have my students that when we're going through and doing this, is always to basically write out the formula. So we've got our sales less our variable costs is going to give me my contribution margin, right? Meaning like how much am I basically contributing to the coverage of my fixed costs, which is going to basically give me my net income. By definition, and over here, we've got units per unit and my total. Over here, by definition, break even, if I'm being asked for W, how many units do I need to go through and sell to reach break even? Well, I have to cover my fixed costs, which I determined to be 90,000. Okay. Similarly, if I'm doing this for the other product, basically my fixed costs over here are going to be 83,000. I need to reach break even. So that means my contribution margin must have been 90,000 for product W, 83,000 for product R. So how do we go through and do this from here? Well, we know that our variable cost per unit is going to be 500, right over here for product W. But how do we figure out the contribution margin? Well, if we look up here, I'm told that product W sells for 900. And I'm also told that product R sells for 800. So right up here, I'm given this data, R sells for 800, while W sells for $900 each. So coming over here, my variable costs over here for product W now. If I come over to this part here, my contribution margin for product W, right, must have been per unit, must have been $400 per unit. That means, and remember, there's a relationship between all of these. That means I must have had a contribution margin for 225 units. That means to reach break even, I have to go through and sell 225 units of product W. Now, what's another way? And let's go ahead and do this also for product R. If I had over here, if I had my sales for product R were 800, I determined that my variable costs were going to be at 600. That means my contribution margin must have been $200 per unit. That means because of the relationship of their units times the per unit, right? My units over here must then be at 415 units. So if I have a contribution margin of 415 units, I must have gone through over here and basically sold over here in terms of sales. And I had variable costs over here. So the number of units to break even for product W are going to be at 225. The number of units to achieve break even for product R are going to be at 415. Now, are there some other ways I could have gone through and solved this? Sure, right? Let's go ahead and take a look. Let's pull up some of these nice ratios over here. Okay, so I'm going to come back over here, go here to problem 7 solution, and let's check these out. So the first thing I need to do is that I could basically say over here, well, my break-even point in units is I could say, well, for product W, my fixed costs were over here, we're at 90,000. My contribution margin per unit, remember the contribution margin per unit is my sales price per unit. Minus my variable cost per unit. Okay, that's basically my contribution margin per unit. My contribution margin per unit is at 400. Therefore, my break-even point in units is going to be at 225. Now, what about my break-even point in sales dollars? Okay, well, again, it's going to be my fixed cost divided by my contribution margin ratio. Well, what's my contribution margin ratio? It's going to be my contribution margin per unit divided by my sales price per unit over here. And if I take this beautifully number done over here, I'm going to get 202,500. And let's just kind of make sure that this is, yeah, this looks good. So again, for myself personally, right, these ratios can be great, but I always like to go through and plug it through the formulas, right? And it makes it so much more definitive. And especially if you're taking my class, what I like to do during exams is I'll say, well, what if the sales price went up by 20%? And then what happens if fixed costs go down by 20 grand? What goes on next, right? So if you go through though, and you put in the hard values into this, then you can just kind of go through and skip these formulas. Well, let's go ahead and do this for the other part over here. Well, my contribution margin ratio over here is going to be at 200 divided by the sales price, or at 25%. My break even in sales dollars, if I take 83,000 divided by 0.25, I should get 332,000. If I were to do this in units, I can take 83,000, my contribution margin per unit. So I've got over here my break-even point in units is going to be 415. Okay, so that takes care of this part right over here. Now let's go ahead and take a look at this next part over here, which is going to essentially be the margin of safety. Okay, so, and it's asking us for what is the margin of safety in both dollars of sales and also in terms of units. Now, if we kind of go through and look at this, we also have to have some other data. Is that how many units were actually sold, right? So, and it tells us here that I sold 300 units of W and 505 units of R. Well, what exactly does this mean? Margin of safety is really comparing our break even, right, to the level of production where we currently are. So what I'm going to do over here is I'm going to say, well, if our sales were for product W, we're at 300, and my per unit is at 900, then over here, my total sales at 300 units would be 270,000. So my margin of safety really between what I'm currently selling and reaching break even is going to be in sales dollars is 67,500, or the difference also between how many units I sold versus the units sold at break even. So my margin of safety in dollars is going to be 67,500. My margin of safety in units is going to be at 75. And if you're taking my class, I will be kind enough because I do not allow any sorts of extra sheets of paper. And right over here, again, the margin of safety formula measures the difference between actual or budgeted sales and the break-even point, indicating how much sales can drop before a business becomes unprofitable. Higher percentage signifies a lower amount of risk. So I'm coming over here, and then I'm going to go back to this part right over here. I'll just copy these in. So do the same over here for product R. So over here for product R, I'm told that I sold 505 units. This was selling for $800 per unit. So my margin of safety in sales dollars is going to be my sales at my current level of production minus the sales at break even. Or over here, it's 72,000. Over here, this is going to be my units sold minus my units at break even, or this is going to go ahead and be at 90. So right over here, you're going to go ahead and have this at 90. And then my break-even point in terms of dollar, basically my margin of safety and sales dollars is at 72. So this right over here is an example of going through and determining the margin of safety. And obviously over here, if given certain costs, as well as we know that there's a relationship between these, there you go. So anyways, thank you for being with me here today. By the way, if you ever got a question where you're coming up with saying like, well, my break-even point is like, say if it wasn't over here, say if it was like 225.13, just round it up to the nearest whole unit. It's going to be slightly off, but we can't really sell fractions of units. And that just kind of sometimes happens with us accounting professionals. Not our accounting professors not going through and doing our Excel in advance. So anyways, thank you so much for being here today. I look forward to seeing you on the next video. And if you have any topics you want me to go through and cover, please feel free to leave a comment below. I'll see you on the next video. Have a great day.